On the morning of June 7, 1944, just one day after the initial D-Day landings, a new and terrifying reality emerged from the coastal smoke at Crépone, France. 2 miles inland from Gold Beach, 2 British Churchill tanks lumbered out of the morning mist toward a stubborn German battery position that had successfully resisted conventional infantry and artillery attacks. To the German defenders manning the 100mm, 88mm, and 475mm guns, the approaching armor appeared odd, as each tank was towing a large armored trailer behind it. The purpose of this peculiar configuration was unknown to them until the tanks opened fire. Instead of the expected high-explosive shells from their main guns, the Churchills unleashed jets of liquid fire, streaking orange and yellow across 80 yards of open ground. The effect was immediate and apocalyptic. The flame didn't just strike the exterior of the defenses, it flowed, filling trenches, bunkers, and gun pits completely with searing heat. Within moments, white flags appeared above the devastated position. 64 German soldiers surrendered, leaving their battery intact, for the cost of a handful of flame bursts. British forces had neutralized a fortified position capable of wreaking havoc on the landing beaches. The weapon responsible for this swift, terrifying victory had a name that German troops across the Western Front would soon learn to dread. The Crocodile. The terror generated by the Crocodile was not mere propaganda. It was a visceral reality experienced by those on the receiving end. At Juno Beach during the initial invasion, Oberleutnant Cornelius Tauber of the 716th Infantry Division had faced one of these mechanical monsters. His post-war testimony offered a harrowing glimpse into the experience, describing it as completely horrific. He recalled a jet of burning orange yellow liquid that radiated such intense heat, it singed his skin and burned hair from 20 meters away. Men were incinerated where they stood as the trenches filled with the burning fluid, the sickening smell of fuel and searing flesh permeating the air. Tauber noted that the weapon created an environment where breathing became impossible as the fire consumed the surrounding oxygen. This testimony was consistent across the front. German soldiers quickly came to understand that this flame reached areas where they believed nothing should burn. The psychological impact was so profound that Wehrmacht commanders issued standing orders regarding the weapon, and captured Crocodile crews allegedly faced summary execution due to the sheer hatred and fear the weapon inspired. The British military acknowledged this unique danger, granting tankers operating these vehicles an extra 6pence per day in danger money. The creation of the Crocodile was born out of a desperate strategic necessity that had become clear by mid-1944. Allied forces were facing a tactical problem that conventional weaponry could not solve effectively. The German defensive positions throughout Normandy were not merely fortified, they were masterfully engineered for survival against modern firepower. The landscape was dotted with concrete bunkers, boasting walls 3 feet thick and machine gun nests cunningly concealed within Norman farmhouses, protected by 2-foot-deep stone walls. These positions were sited for interlocking fire, creating kill zones that made direct infantry assault tantamount to suicide. Furthermore, the infamous bocage country turned every hedgerow into a concealed fighting position, and every village was transformed into a miniature fortress. In this environment, infantry attacks stalled with horrifying regularity, and casualty rates soared. British infantry battalions frequently suffered 30% casualties, struggling to take a single village. Artillery, while powerful, often couldn't crack the reinforced bunkers, and tank guns were unable to reach positions situated in defilade. The reality of this tactical stalemate was starkly illustrated in late July 1944 on the 53rd Welsh Division's front, where 3 full battalion attacks involving hundreds of men failed successively against a single, resolute German machine gun nest. Similar frustrations plagued American forces at Brest, where they faced 18th-century stone fortifications that absorbed days of heavy bombardment without yielding. Fort Montberry alone tied down an entire U.S. corps. The fundamental problem confronting the Allies wasn't a lack of courage or a deficiency in conventional firepower. It was a problem of physics. High explosive munitions rely on blast and fragmentation to kill, both of which lose their effectiveness significantly against thick earthen walls, reinforced concrete, and deep subterranean bunkers. To root out defenders in such scenarios, an attacking force needed a weapon that didn't just explode on impact, but could flow around corners, follow corridors, and penetrate into enclosed spaces. This fortification challenge was omnipresent throughout the European theater. In the shattered city of Caen, German forces utilized the very rubble created by Allied bombing to construct formidable defensive positions that were often superior to intact buildings. Every pile of shattered concrete could conceal regular machine gun team, and every collapsed cellar served as a makeshift bunker. In essence, the artillery preparation intended to soften defenses often created the exact terrain the defenders needed. The Atlantic Wall fortifications along the coast presented similar, highly engineered challenges. The Todd organization had constructed positions specifically designed to resist heavy naval gunfire and aerial bombing, using steel-reinforced concrete, measured in meters rather than centimeters. Gun embrasures were narrow slits, presenting almost impossible targets for direct fire, while underground trench systems connected positions where airburst artillery couldn't reach. German engineers, having studied the trench warfare failures of World War I, designed these positions to survive modern firepower. The Allied predicament was clear. The 17-pounder anti-tank gun could kill a Tiger tank at range, but it couldn't crack thick bunker walls, and the 75mm high-explosive rounds fired by standard Sherman and Churchill tanks merely shattered against concrete faces. The Germans were well aware of the limitations of conventional arms against fortifications, having pioneered the use of flamethrowers since 1915. However, man-portable systems had severe drawbacks. While models like the Flamethrower 35 could reach 25 meters, and later versions pushed this to 30 meters, the operator was exceptionally vulnerable. Carrying 70 pounds of highly flammable fuel and compressed gas made the soldier a slow-moving, high-priority target for every enemy rifleman. Recognizing this, Germany began mounting flamethrowers on armored vehicles by 1943. The resulting Flampanzer III carried 1,020 liters of fuel and had a maximum range of 60 meters. However, when deployed at Kursk in July 1943, the results were unsatisfactory, and the program was terminated after only 100 units were built. American forces also attempted to bridge the gap with auxiliary flamethrowers for their Sherman tanks, such as the E-425 system. This auxiliary setup used the bow machine gun mounting and carried a small fuel load of around 190 liters. Its effective range in European theater demonstrations was dismal, managing only 35 to 65 yards. British post-war assessments described the American system as positively pathetic compared to the Crocodile, a sentiment shared by American troops who repeatedly requested British flame tank support throughout the campaign. British forces desperately needed a superior solution, something armored enough to survive the approach to fortified positions, with enough fuel capacity to sustain operations, and capable of projecting flame further than German defenders could effectively shoot back with small arms. Crucially, the design needed to address the primary flaw of all previous flame tanks: crew survivability. Every other Allied and Axis flamethrower vehicle stored its massive fuel load inside the hull, along with the crew. A single penetrating anti-tank hit turned the vehicle into an instantaneous coffin, incinerating the crew within seconds. The requirement for a better system reached the British Petroleum Warfare Department in 1940. Under the direction of Donald Banks, an early attempt, the Churchill Oak, designed by Major J.M. Oak, mounted a flame projector in place of the hull machine gun. 3 prototypes were sent to Dieppe in August 1942, but all were disabled before they could engage, contributing nothing to the disastrous raid. The British War Office initially drew the wrong conclusion from Dieppe, rejecting flame tanks entirely in favor of man-portable or light carrier-mounted systems. Fortunately, the Petroleum Warfare Department ignored the official policy change and continued development. The breakthrough occurred in March 1943, when Major General Percy Hobart, commander of the 79th Armored Division, the unit designated for specialized armored development, witnessed a demonstration of an improved flame projector. Hobart, already a champion of unusual engineering solutions like flail tanks for mine clearing, immediately recognized the weapon's potential against fortifications. Leveraging his connection to his brother-in-law, Field Marshal Bernard Montgomery, Hobart pressured the Ministry of Supply for accelerated production. General Sir Alan Brooke made the decisive call on March 11, 1943, allocating Churchill tanks to the 79th Armored Division for conversion. The development team, having learned from previous failures, faced the challenge of solving 3 critical problems simultaneously: vulnerability, insufficient range, and limited fuel capacity. The ingenious solution to the storage and vulnerability problem came from analyzing railway fuel tenders, an external trailer. The immediate objection was that a trailer would severely limit mobility. However, engineers countered that flamethrower tanks were intended to reduce static fortifications methodically at close range, not pursue fleeing enemies across open country. Therefore, the mobility trade-off was acceptable. Extensive trials proved that a Churchill towing a loaded 6.5-ton armored trailer could traverse rough terrain adequately adequately. Where the tank went, the trailer followed. The coupling mechanism required precision engineering to handle the immense stresses, eventually incorporating a crucial safety feature, a Bowden cable quick-release system. This allowed the crew to jettison the trailer instantly from inside the turret if it was hit or if tactical mobility became paramount, saving both the crew and the base tank. The flame projector mechanism itself required equally precise engineering. A nitrogen propellant system using 5 cylinders of compressed gas had to deliver consistent pressure. Too little pressure and the flame fell short, while too much dispersed the fuel spray, reducing its effectiveness. The ignition system needed absolute reliability under combat conditions, leading engineers to build in redundancy for the spark plugs. Perhaps the most critical development was the fuel mixture. Chemists at the Petroleum Warfare Department tested various thickening agents to create fuel that would flow reliably, yet burn intensely and stick to surfaces upon impact. The result was FTF heavy, No. An optimal compromise that flowed in varied temperatures, ignited reliably, burned at extreme heat, and adhered tenaciously to targets rather than running off. Live-fire testing against purpose-built concrete bunkers, trench systems, and stone building mock-ups generated the data necessary to refine the system into a devastating weapon. The resulting vehicle, named Crocodile after its long, armored tail, was revolutionary. The trailer carried 400 imperial gallons, 1,800 liters of fuel, protected by up to 14 millimeters of armor plate, connected to the tank via armored piping running beneath the hull. The system could deliver fuel at 4 gallons per second, providing approximately 100 1-second bursts, or 25 sustained 4-second bursts. The flame projector replaced the hull-mounted Besser machine gun, achieving a maximum combat range of 80 to 110 yards, with an effective killing range of 80 to 90 yards. This range was substantially greater than German man-portable systems, the failed Flampanzer III, or the American auxiliary systems, and significantly more sustainable than Soviet OT-34 flame tanks. Crucially, the Crocodile was based on the heavily armored Churchill Mark VII, which boasted 152 mm of frontal armor. Unlike any other flame tank of the war, the Crocodile retained its standard 75 mm main gun and coaxial machine gun, allowing it to fight as a conventional heavy tank. When not using flame or after jettisoning its trailer, the production order for 800 conversion kits was placed in October 1943, before troop trials were even finished, emphasizing the urgency of having the weapon ready for the imminent invasion of Europe. 3 regiments, the 141st Regiment, RAC, the Buffs, the 1st Fife and 4th Yeomanry, and the 7th Royal Tank Regiment trained intensively through the winter and spring of 1944. The Crocodile represented the pinnacle of British wartime engineering under pressure, moving from a defined requirement in 1942, an operational solution by June 1944, solving complex problems that German and American designers had failed to crack. Its combat debut on D-Day was inauspicious due to rough seas and terrain obstacles, but the engagement at Craponne on D-Day +1 proved its worth, establishing a pattern that would repeat across northwest Europe. Following the success at Craponne, word of the Crocodile's terrifying capabilities spread rapidly among German forces. The tactical advantage of the weapon was often psychological. Crews developed the tactic of firing a warning shot of unignited petroleum jelly onto a bunker or trench. The defenders inside would see the thick, flammable liquid coat their position and face a stark choice: surrender immediately or burn. Many chose surrender, accepting the Crocodile's offer of mercy. On July 23, 1944, on the 53rd Welsh Division's front, a single Crocodile troop broke a deadlock where 3 infantry battalions had failed. The German machine gun position surrendered at the mere sight of the distinctive tanks approaching, allowing the infantry to take the objective with 0 casualties. Similar scenes played out during the closing of the Falaise Gap in August, where SS troops, typically known for fighting to the death, surrendered rather than face flame tanks, blocking their escape routes. The weapon proved equally effective in urban combat and against hasty defenses. At Troon, Crocodiles supporting Canadian forces burned German troops out of fortified buildings, turning the structures into ovens and forcing the defenders to choose between suffocation, immolation, or surrender. In September 1944, the Crocodile was instrumental in reducing the heavy fortifications of vital port cities like Le Havre, Boulogne, and Calais, where conventional assaults had stalled at high cost. The statistical evidence of the Crocodile's impact was staggering. In 31 engagements engagements in Normandy. Crocodiles killed 134 enemy soldiers with flame but caused between 1,500 and 2,000 to surrender, directly a ratio approaching 15 surrenders for every death by fire. The weapon broke the enemy's will long before it destroyed their bodies. German tactical doctrine evolved specifically to counter this unique threat. Wehrmacht anti-tank gunners were ordered to prioritize the armored trailer, hoping to neutralize the psychological weapon before it reached effective range. Standing orders instructed infantry to evacuate forward positions immediately if flame tanks were identified, acknowledging that troops in the direct path of a crocodile could not survive. This doctrine meant that the mere presence of crocodiles could force German withdrawals. The siege of Fort Montbarry at Brest in September 1944 demonstrated the weapon's ability to crack positions immune to conventional arms. The 18th century stone fort, impervious to heavy artillery bombardment, fell after sustained flaming by crocodiles forced smoke and phosphorus into the suffocating the garrison and compelling their surrender. The superiority of the crocodile over contemporary systems was absolute. The German Flammpanzer III was a failure due to its deadly internal fuel storage and short range. The American E-425 auxiliary system lacked the range and power to penetrate dense Normandy hedgerows, leading American commanders to frequently request British crocodile support. Soviet flame tanks, while more numerous, lacked the sustained fuel capacity of the British design. The crocodile's unique combination of heavy armor, retained main armament, external fuel storage for crew survival, and unmatched fuel capacity made it the most effective flamethrower tank of the war. Its legacy extended beyond 1945, with crocodiles deploying to Korea in 1950, where they served primarily as reliable, heavily armored gun tanks in the rugged terrain, proving the soundness of the basic Churchill design years after its contemporaries were obsolete. While the crocodile itself was retired in the early 1950s, the concept of specialized armored engineer vehicles pioneered by Hobart's 79th Division influenced generations of subsequent vehicles. Like the Centurion, Avra, and modern combat engineering tanks, the crocodile remained a singular achievement, a weapon born of necessity that used terrifying physics to solve an impossible tactical problem, leaving a lasting scar on the memory of the German forces that faced it.